Hey guys, what's up? In today's video, we will be talking about Vieta's formulas. This is a powerful tool in mathematics that allows us to look at the sum and the product of the roots of a quadratic without actually factoring the quadratic first. This is particularly useful in situations when you have limited information about a quadratic or you're just trying to save yourself some time, especially like during math contests and stuff. So let's start with the derivation of this formula. Starting with the standard form of a quadratic, ax squared plus bx plus c, where a, b, and c are integers. Let the roots of this quadratic be x equals r and x equals s. So this quadratic should be factorable as a times x minus r times x minus s. So let's start by expanding this one out. This will give us a times x squared minus rx minus sx plus rs. And factoring or distributing the a out gives us ax squared minus a times r plus s x plus ars. So relating this to what we have in black, we can kind of see that the a term corresponds to a, b corresponds to minus a times r plus s, and c corresponds to a times rs. So solving for r plus s and rs, respectively, the sum and the product of the roots, we get r plus s equals negative b over a, and rs is equal to c over a. So yeah, this is basically the short form of Vieta's formulas for a quadratic. So as we can see here, we don't actually need to know how to factor this quadratic. Instead, we just look at negative b over a and c over a to find the sum and the product of the roots respectively. So let's try this out on an example. X squared minus 5x plus 6. So let's try to find the sum and the product of the roots of this quadratic without actually factoring it first. Um, Okay, so r plus s, the sum of the roots is going to be negative b over a, which is in this case negative 5 over 1, which is equal to 5. The product of the roots rs is equal to c over a, which in this case is just 6 over 1 equals 6. So there we have it. Just to double check this, let the roots be 2 and 3, because these both sum to 5 and they both multiply to 6. So x minus 2 times x minus 3. Expanding this one out gives us x squared minus 5x plus 6, which is what we have in black. So yeah, this is basically how Vieta's formulas work for a simple example. So now let's try another example. 7. So sum of roots equals 7, and product of roots equals 10. Now let's try to find a quadratic for which this is true. So the sum of the roots, as before, I'm just going to write this out, is equal to negative b over a, and the product of the roots is equal to c over a. So seeing how they're both dependent on a, let's just set a equal to 1, just to make things simple. And so for that, I'm going to have x squared plus bx plus c. So now r plus s is equal to negative b, and rs is equal to c because we set a equal to 1. So now our quadratic is just going to be x squared, since the sum of the roots is 7, and that means b is going to be minus 7, and the product of the roots is 10, so c is just going to be 10. All right, pretty simple, right? All right, so now let's look at a more difficult type of example. The example that you see here might resemble an introductory type AMC level problem. Basically, we're going to have to do a little bit more thinking, and problems like these we're going to try to solve a bit faster. So the roots of x squared plus px plus q equals 0 are both one more than the roots of x squared plus 3x plus 2 equals 0. So find p and q. The first thing we're going to do here, notice how it gives us information about roots, and we're trying to find coefficients. This is a green light for Vieta's formulas. So first I'm going to start with the information they give us. This quadratic, let the roots be r and s. So using Vieta's formulas, the sum of the roots here is going to be r plus s is equal to negative b over a equals negative 3 over 1 equals negative 3. And product of the roots is going to be c over a, which is equal to 2 over 1, which is equal to 2. Okay, so far so good. So now for this quadratic, the roots are each going to be one more than the roots of this quadratic, so they're going to be r plus 1 and s plus 1. So the sum of the roots in this case is going to be r plus 1 plus s plus 1 equals r plus s plus 1, plus 2, my bad, which is equal to negative 3 plus 2, because we already found r plus s here, and it's going to be negative 1. The product of the roots is going to be r plus 1 times s plus 1, which is going to be rs plus r plus s plus 1, which is going to be rs is 2, r plus s is negative 3, and plus 1 equals 0. Okay, so far so good. So now looking at this quadratic here, the sum of the roots is going to be negative b over a, which is equal to negative p. And since a is 1, it's just going to be negative p. And the product of the roots is going to be c over a, which is equal to q, since a is 1. And here we calculated the sum as negative 1, so negative p equals negative 1, and the product is going to be 0. So we know that q equals 0 and p is equal to 1. Or you can write p equals 1, q equals 0. It doesn't matter for the order. We're just trying to find p and q. And so, yeah, that's kind of it for this video. Vieta's formulas, they aren't just cool, as you might have seen, they're pretty powerful. So whether you're in algebra class or solving AMC problems, these formulas are useful in saving time and deepening your understanding of numbers and quadratics in general. So I hope you found this video helpful. If you did, feel free to drop a like and make sure to subscribe to see some more math tips and videos coming your way. In the next video, we will look at applying quadratics to the real world, from physics to revenue optimization. So yeah, see you guys next time.